Okay, Assalamualaikum warahmatullahi wabarakatuh. This is Statics Chapter 10.2. We will be dealing with parallel axis theorem and also moment of inertia for composite areas. Right. In the previous lecture 10.1, we actually have introduced the equation for parallel axis theorem. So basically, we will be seeing that equation yet again, and then but right now the application is for composite areas. Right. So in terms of the concept we have discussed in the previous lecture, so just refer to that lecture for the idea of moment of inertia. But this is related to the real structure where most of the structure is combination of basic shapes. For example, when you have T, it's basically just rectangular here plus rectangular here, right, etc. So we might not, because if it's a basic shape, then sometimes not every time we need to integrate, right? We can just refer to the table, for example. So and the actual equation also, I'll skip the derivation, I'll straightway go to the equation. So the parallel axis theorem is simply the equation Ix equal to Ix prime plus a dy squared and Iy equal to Iy prime plus a dx squared. Right? So that is the equation. Now, so just to reiterate, because everything have been explained in the previous lecture, and I assume everyone who is watching this already watched the previous one also, but just to refresh a bit, so I'm not going into detail because we have gone into detail in that lecture. Of course, for me it's just now, because if you notice, I'm still using the same sheet. It's just straight away after recording that one, I record this one. And anyway, so basically, if you have the x prime axis and x axis, the distance between this is dy here, right? And the area is A is just the area, and x prime axis by definition is the x-axis that goes through the centroid. Y prime axis is basically just by definition is y-axis that goes to the centroid. Meaning that if you have centroid here, this is x prime, this is y prime, right? By definition. So if you have x-axis here, for example, then dy is the distance between the two, etc. Right? So I think for today, for the application for today, there's no integration involved. So it's quite straightforward. I think everything will be clear when we do the example, inshallah. Right? So radius of gyration we totally skip. Right? So moment of inertia for a composite area. Right? The step is simple. Right? So if you have any particular shape, you divide into some basic shape, right? And some division is can be additional or subtract, right? If you have a hole, it's subtract that area. That's number one. And we will go into the example. It should be clear after this, right? And step number two, you locate the centroid, because we need the centroid of each, just like this, right? We locate the centroid of the area, this particular area, and you also you need to know where is the axis that the question asking. For example, this one, x-axis. So this one will be dy, for example. That's the purpose of locating where is the centroid. And third, you just apply parallel axis theorem, and then you can solve, right? So it's quite straightforward. And basically what you are solving is for that particular area. So basically in the end, you just add or subtract to have the summation of the moment of inertia as a whole, right? So I think the concept is very easy. We'll just go straight into the example, right? Okay, what is going on? The focus is already, I'm not sure what is going on, because is it something? Okay, hopefully the focus stays good as like this. Bismillah, Bismillah. Alright, so first I will put, inshallah, the example here, meaning the shape here over this side. So for this shape, basically we have to find what is the given is the beam cross section. Find the moment of inertia of the area about x-axis, and yeah, and we skip the radius of gyration part. So find the moment of area, moment of inertia about x-axis, right? So take note of the shape just now, right? So for this shape, basically what we have is, it's a combination of, okay, I will draw something like this, right? Okay, the aspect ratio is okay, I use blue. Right? That is the question, the area, and the axis, the x-axis is exactly at the middle, I believe. Right? So because we want to find about x-axis, so y-axis become insignificant in this question. Okay, the focus. So, basically this is the area, and the axis is basically here, x-axis. The question is about that x-axis, right? So that's the first thing that you have to understand. Now, basically when you divide the area, my suggestion is you draw straight away with respect to the axis, right? For example, basically you divide into 1, 2, 3 area, right? So the first one, so this equal to this shape over here, right, with respect to this axis, plus this shape over here with respect to x-axis, plus the shape down here with respect to x-axis. Is it still in the frame? It's still in the frame, right? At the end there. Alright. So this is important to avoid mistake, right? It's not compulsory, but it's more easier to avoid mistake if you have it visual, right? So please have a habit. This is my suggestion. It works for me. Hopefully it works for you too, right? Right. So basically you understand, right? This is area number 1, number 2, number 3. You add together, it becomes this area. And I straight away you draw the x-axis so that it's avoiding mistake measure, right? Now, because what we need is just this one, right? So if you identify, what you need is from the equation is dy and also a, right? And in this case, all the rectangular shape is 1/12 bh cube, right? Yeah, because it's ix, right? So the question is, where is the centroid of the area itself? So the centroid is here, right? So the x prime axis will be here, x prime for that one, right? In this case, where is the centroid? Basically here. The x prime is exactly the same as x for that shape, right? For the other shape, x prime will be here, right? Why do we draw that? Because dy is basically from x to x prime, right? The distance between the two. So that with one, the distance is, what is the distance? Okay, hopefully you take note of the original drawing, right? So basically from here you have, this one is 50, this one is 300, this one is 50 millimeter. Everything is millimeter here. So this is 50, 300 and 50. So given that this one will be 150 plus 25, right? 150 plus 25 becomes 175, right? And this one is exactly the same position. This one is still 175, right? 150, which is half of the 300, plus 25, which is half of the 50, right? That's number one, what you need, which is dy. What about a? A is simply, in this case, this is, okay, what's the width? This is 200, right? This is 200. So this is 200 times 50. This one is the width 50, right? This is 50. So this is 50 times 300. This is 200 times 50. Now, if you have done all of that, all of the information is already there, right? So basically you are ready for calculation. So basically Ix is basically just the summation of Ix for this one plus Ix for that one plus Ix for that one, and each Ix is basically Ix prime plus a dy square. So for this one, Ix prime is 1 over 12. So basically for all of this, Ix prime is 1 over 12 bh cubed, right? This one is valid here, same as here, same as that, right? 1 over 12 bh cubed. So you put in stick with the value, it will be 1 over 12. B is this base here, 200. H is 50, and then you have cube there, right? Is it too small? Hopefully you can see. You can see, right? Is it too small? Okay, I will write it a bit bigger. 1 over 12. B is 200. H is 50, and then you have cube. That is 1 over 12 bh cube for Ix prime. And then plus a dy square, right? A dy square. Plus a. A is 50 times 200. And then dy square. Dy is 175, and then you have square, right? So this is basically Ix prime plus a dy square for this one. And then you just add for this one and add for that one, right? So add here. 1 over 12 bh cube. B is 50, h is 300 cube plus a dy square. So a is 300 times 50, and then okay, this is 0 square, right? Because x and x prime is the same, right? Or basically this is just Ix is just equal to Ix prime. There's no additional here, right? But I'll just put it there so that you understand if you are confused. Then plus 1 over 12 bh cube. B is 200, h is 50 cube, and then plus a 250, and then dy square, which is 175 square. Is it still in the frame, that square? I think so, right? Alright, so basically that Ix is just the whole thing you add becomes, in this case it becomes millimeter to the power 4, right? Because I input all the data in terms of millimeter. So obviously this one is millimeter to the power 3 become millimeter to the power 4, or same here, right? Millimeter square become millimeter to the power 4. So that is the value that you will get, right? So if I take a look at the answer from the slide, it is 7.291 times 10 power of 8. Right? 7.291 times 10 power of 8 millimeter to the power 4. That's the answer. Hopefully it is clear, because sometimes I see it's losing focus. This camera is alright. Now, for the concept quiz, if you have the slide, refer to the concept quiz. Please do try to answer this question, because I really want to. Normally, if in the class, I like to ask this question, because this kind of question, it does require you to give feedback so that I can explain. If I just explain here, it's quite weird, right? So please try that one, concept quiz. If you do not understand or you do not know, ask me in class. Do not forget to ask me in class. Someone so that we can discuss, right? If it's clear, then it's clear. Right, we have another problem, which is group problem solving. So I will erase this, and you just maybe I'll put the diagram somewhere. I'll erase this and we'll continue with this example. Alright, so we have the shaded area, so the area is hopefully there. We have the shaded area shown in the figure, so from the figure you can see that that's basically a combination of some rectangle, triangle, and a circle, right? Find the moment of inertia for the area about x-axis and the radius gyration kx, right? So I'm not sure why, but normally the question from the slide is just the simplest, so that you know how to apply the equation. So that's why it's always asking for x, right? But in the exam, it can ask for about y-axis, for example, moment of inertia about y-axis. But for that, do watch also if you need, if you are missing the class or you didn't attend the class, do watch also the recording for the class, right, where we will actually cover the exam question of the past, so that it is more to the level of the exam, right? Here is just very simple. This one is very simple, right? But anyway, so let's learn the steps. Basically, the shape is basically like this, right? So you have the shape like that. So something like this, correct? X and Y, and you have basically a middle here. You have a circle here, right? I think it coincides with the center there. All right, something like that. Yeah. And the dimension, I think you should take from when I posted the picture just now. Take all the dimensions, right? Right. So basically here you have several ways of dividing the shape, the area, right? So let's do this. Let's do basically this rectangle. Is it square rectangle? This is rectangle here, plus this triangle minus this circle, right? So in that case, this equal to, if I redrawing, hopefully it's a bit smaller. So, and the question is, make sure you understand the question. The question asks, what is the moment of inertia about x-axis? So our base is always x-axis, right? So first the rectangle. So this is the x-axis, and you have the rectangle like this, right? And it's basically, this is 300 and this is 200, right? And this is x. And then you have to add the triangle there, where it has x there also. So this one is 150. This is all in millimeter, right? 150, and then this is 300, right? And then you minus the circle, minus the circle. The circle have x-axis down there, and this is where the distance. Okay, the distance will take after this, right? The radius is 75 millimeters. So this one is 75 millimeters, the radius, right? So again, what we need is all the area, and also based on this equation, ix prime plus a dy square. So we have to have a and we have to have dy square, right? So a is simple, right? This one is straightforward, a. So what we need is dy square. So what is dy? So the centroid is obviously here for x prime. So dy here is half of that is 150. Straightforward. This one, centroid is here, and you should know by now the ratio is 1/3 and 2/3, right? Meaning that This one is 1/3 of 300, which is 100. Right? And then you have the circle there, the centroid is exactly at the middle there, and the distance here is given as 150. So that is basically all the information that you need for your calculation, right? All of those. Hopefully my drawing is not too small. Hopefully you can still see all those things that I write. If it's too small, I apologize. Right? So basically, and then the step is just like before. You just apply this equation here, ix equal to ix prime plus a dy squared. So, and then you add everything. However, this one is minus, right? So make sure you understand that. Okay, so in this case, ix equal to, so basically ix, okay, because it's not the same line. So okay, I write so ix equal to, now, okay, we have to refer to the table for this one, right? Because we only memorize for 1/12 pH cube, right? So where is the table right now? So alright, I just found the table from, because I didn't bring my textbook here, but I just saw this in from the previous exam question. So hopefully I'll put it here right now. So hopefully I'll put it here right now. And if you can see, for rectangle, just see the table. For rectangle is 1/12 pH cube, right? We are, for this question is about x-axis. So for rectangle, you can see 1/12 pH cube, right? And for triangle, we have ix is 1/36 pH cube, and for the circle, ix equal to 1/4 pi r to the 4. Alright, so coming back here, so we just write that down at each of our shapes so that we do not lose track, right? This is suggestion for the exam, right? So for this one is basically the ix prime is 1/12 pH cube. For triangle, 1/36, right? So ix prime here is 1/36 pH cube. For circle is 1/4. So ix prime here is 1/4 pi r to the power of 4. Right? This one, all of those values you have seen the table just now, right? Hopefully you know how to refer to the table, right? Unless you want to memorize everything. Right? This one is easy to memorize because we deal with rectangular a lot, right? If you do enough exercises. But this one, yeah, I don't have enough capacity of memory, but if you memorize, it's also okay. Right? So, but normally if this kind of question comes in the exam, you will have the table in the exam, right? So just know how to refer to this. Now, so again, ix is equal to ix prime plus a dy squared, and we already write all the ix prime. So we'll just write the value here. So for this one, 1/12 pH cube. B is 200, H is 300. So you have cube 1/12 pH cube plus A. A is basically 200 times 300, and dy squared. Dy is 150 squared. Right? So again, the question once you have divided and you have all the relevant information is just straightforward, right? So as I mentioned, always chapter 9 and chapter 10 is very straightforward if you understand, right? Make sure you understand to get full mark for these two chapters. Now plus here still ix prime plus a dy squared. So plus here 1/36, b is 150, h is 300 cube, and then plus a dy squared. A is area of rectangle is half times 150 times 300. That's the area. dy square. Dy is 100 then square. Right? This is minus, so it should be minus and minus the whole thing, right? So not sure how you want to write. So if you will have minus here, right? So minus this one 1/4 pi r is 75, so 75/4, and so minus a dy square. So a is pi r square, so pi 75 square a dy square. So dy is 150 square. Right? So basically you have that one, and then the rest is just calculation to get whatever value here. So if you calculate, it should be 1.715 times 10 power of 9 millimeter to power of 4. Right? So as you can see, it's not difficult. It's quite straightforward, all of this. Right? So the question cannot trick you that much, right? It will always just be like this. So what else? Yeah, nothing else. So as long as you know the equation, of course do try for IY, because in this slide they always ask for IX, and yeah, straightforward. IY is also straightforward. It's just that if you have never tried it before, because it will be reflected to this one, right? Okay, just for the idea, right? I'll just draw how it will be for IY, but I will not calculate. You know how to calculate, right? So for this one, so you have y-axis and then rectangle, right? And then plus you have y-axis and then the triangle like this. So you notice here the dx will be something here, right? So make sure you know that. And then minus, you have y-axis and then the center, the circle, right? So it's something like that, right? So the concept is the same, it's just that, and then you identify what is the area and what is the dx, sorry, dx and dx. This is for IY, right? So just try. It should be straightforward also, and if you understand everything, it shouldn't be that difficult for your exam, inshallah. So that's the end of this one. So this is quite short, this part. Yeah, the rest is just, we will see the exam question in the lecture in the class. So if you want to see that, refer to the playlist for the chapter, for the playlist for the class recording for that chapter. If you do not know where that is, or you struggle to find where the playlist is, in case, just ask in the comment and I will lead it. I will give you the link to that recording, inshallah. Wallahu alam. So this is the end of chapter 10. Yeah, hopefully everything is okay. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.